Yeah, we can see.
Yeah, so welcome
Yeah,
everyone in
yeah,
this
perfect.
welcome everyone in this talk. I'm very thankful for inviting me in this webinar. And today I'm going to talk about Z inspection, which is a process to assess trustworthy AI. Z inspection is a registered trademark and it is open for everyone to use under the license of Creative Commons. I am an I am a founding member of the Zine inspection process. My hope from today's presentation is that after this talk, you will be more aware about what trustworthy AI means and what you can do yourself to assess whether an AI is trustworthy or not. So AI is having an unprecedented impact in our everyday life. It is used to recommend products, services, entertainment, news, healthcare, loans, jobs, education courses, as well as even a life partner. At the same time, there is also a growing concern on the ethical and societal implication of those AI. And one of the questions that we often ask ourselves is that how do we know whether the AI is trustworthy or not? Even a more basic question is what is the definition of trust? And the definition can vary based on the context and domain, but we use the definition given by European Union high-level expert group. And according to them, an AI is trustworthy if it's lawful, respecting all applicable laws and regulations, if it's robust, both from technical and social perspective, and if it's ethical, respecting all ethical principles and values. Their definition of trustworthy AI is based on four ethical principles which are rooted in the fundamental rights of human being, and those are respect for human autonomy, prevention of harm, fairness, and explicability. And they also gave 7 requirements of trustworthy AI, and those are human agency and oversight, which means respect for fundamental human rights, and it requires that human to be in the control. Technical robustness and safety, which includes resilience to attack and security, fallback plan and general safety, accuracy, reliability, and reproducibility. The third requirement is privacy and data governance, and that includes respect for privacy, quality, and integrity of the data, and also have the right to access the data. Fourth requirement is transparency, and that includes interpretability, traceability, explainability, and communication. The fifth requirement is diversity, non-discrimination, and fairness, and that includes avoidance of unfair bias, accessibility and universal design, and stakeholder participation. Sixth requirement is societal and environmental well-being, and that includes sustainability and environmental friendliness, as well as impact on society and democracy as a whole. And the seventh requirement is accountability, and that includes auditability, minimization and reporting of negative impact, opportunity of making trade-off, and as well as the opportunity of doing redress in case of there is any issue with the AI. Now, you might ask, why do we need an inspection or auditing process? Although self-assessment is always welcome and it should be, we should always do self-assessment. The problem with self-assessment is that it is often caused by the conflict of interest. The individual or the group that are building the AI might not see the negative impact of their innovation, and therefore we need a third party to do those, investigate those. Also, evaluation of ethical impact is challenging because evaluating ethical impact not only involve evaluating the impact on the person who is using the AI himself, but also um, impact on those affected indirectly, such as their friends, families, communities, society as a whole, and the planet. Also, some of the ethical impact are only fully understood after deployment in real world. Think about the Facebook and its impact. Also, the claims for the black box models are very difficult to verify for people who are outside the organization. And that's why Turing Out winner scientist Joshua Bengio and his colleagues suggested that a coalition of stakeholders should create a task force of research options for conducting and funding third-party agencies to audit AI systems. The European Commission and the Organization of Economic Cooperation and Development Forum, OECD, they also suggested similar thing, saying that we should develop auditing mechanism for AI systems to allow public enforcement authorities as well as independent third-party auditors to identify potentially illegal outcomes or harmful consequences generated by AI systems such as bias or discrimination. And those are the motivations behind the development of an auditing process such as the inspection. The inspection is a practical assessment process of trustworthy AI that is based on applied ethics, and it can be applied in a variety of domains, including healthcare, business, public sector, and many others. It can be customizable based on use case, domains, and context. And it also allows to use existing frameworks, checklist, tools as a plugins. The inspection focuses on technical robustness, legal and contractual implications, as well as ethical and societal implication of the AI involved. Now, note that illegal and unethical are not the same thing. Also, legal and ethics depend on the context. So far, we have assessed 4 use cases, and these are all real-world use cases. And they are also coming from healthcare domain. We inspected an AI for predicting cardiovascular risk. We also assessed machine learning tool that is used to recognize cardiac arrest in emergency calls in Copenhagen. We analyzed deep learning tool that is used to detect skin cancers. And currently, we are evaluating a deep learning model that is used to predict lung compromise in COVID-19 patient in Italy. This is the founding member of the inspection process, and this team member analyzed the first use case that I'll also talk about in this talk. One thing to note is that this team include multidisciplinary team of experts. So we had computer scientist, we had philosopher, we had legal expert, we had general physician as well as cardiologist. So we really had expert from all the aspect of expertise that we need to assess the use case that we had in our hand. And since then, our team has been grown a lot based on the use case that we were inspecting. We right now have over 30 people collaborating in this inspection process. And here is a list of institution where they are affiliated, and I haven't added all of them. But the main point is that to do this audit or inspection of trust to the AI, we need experts from all those sectors that are impacted by the AI. The inspection is really an orchestration process that helps the experts to assess ethical, technical, and legal implications of a given AI. And the uniqueness of it is that it can be used at different stages of the AI process. It can be used before the production, helping the relevant actors to be aware of ethical, social, technical, and legal risk and pitfalls. It can be used as an auditing process to do ethical evaluation over time of a deployed AI, and we call it ethical maintenance. And we also it can also be used to cover post-audit stage, and that can be used by third-party investigators like even government policymakers to audit the AI for trustworthiness. Here is the inspection process in a nutshell. It has 3 phases: setup phase, assess phase, and resolve phase. And I'm going to talk about each of those in the coming slides. So let's start with the setup phase. We start by checking some preconditions. And the first thing that we do is to make sure that there is no conflict of interest exists between the team of inspectors and the entity or organization being examined. We need to make sure that there is no conflict of interest between the inspectors and the vendor of the tools or toolkits that are used for the inspection. And we also need to make sure that there is no bias among the team of inspectors. And it's a go if all 3 are satisfied. It's still a go with restricted use of tools if number 2 is not satisfied. And it's a no-go if either number 1 or 3 is not satisfied. The next step in the inspection process is to create a log or document or protocol document, which records all the information over time for the inspection process. It includes information of the team of experts, the actions that has been taken as part of the investigation, the steps done in data preparation and analysis, as well as the steps to perform different use case evaluation with the tools. The protocol can be shared with the relevant stakeholders at any time to ensure transparency of the process, and it can be also used to redo some of the actions in the later stage. Next, we define a catalog of questions to clarify the expectations of the stakeholders. For example, who requested the inspection? For whom is the inspection relevant? Is it recommended or required by mandatory inspection, for example, by the government? What are the sufficient and necessary conditions that need to be analyzed? And also how to use the result of the inspection. Is it a verification? Is it for verification? Is it for certification? Is it for sanctions? We also need to understand what would we do with the assessment. Will the result be shared publicly or kept private? And in case if it's kept private, we would ask why the result will be kept private. And it could be related to the fact that it involves intellectual property. And that's why we also need to understand what is under the intellectual property and what is not, and how to handle that IP. We also need to identify possible restrictions due to the IP restriction and what are the consequences of these restrictions, whether we can do the inspection properly with those restrictions or not. Then we need to define if and when code review is possible or needed. And there we need to make sure that there is no risk to the security of the system, privacy of the underlying data is ensured, and also there is no undermining intellectual property. And then we also need to define what are the implications if any of those are not satisfied. At this stage, we will probably have to make some trade-off decisions regarding whether we want to disclose all activities of the inspection versus delaying them to a later stage or not disclosing them at all. The next step in the setup phase is the team building process, where we build a multidisciplinary team of experts, and the composition of team is a dynamic process. The expert with different skill can be added at any time of the process. And note that the choice of expert also has an ethical implication. So if you are analyzing an AI that is used in healthcare, if you don't have healthcare expert, then you are not really doing the inspection right. Next, we also define boundaries of the inspection, where we define the ecosystem of the inspection itself, and that includes sectors and parts of the society involved, levels of social organization which will be impacted by the AI, the publics, and political and economical dimension of the inspection, as well as the AI. We also need to clarify what to investigate, because AI is not really a single element. AI cannot be investigated in isolation. AI is dependent on the domain where it is deployed. AI is part of one or more digital ecosystem. AI is also part of some bigger process, product, and services. And AI is also related to the people and their data. We also need to define the time frame of the assessment. There could be 3 different time frame where the assessment can scope. For example, the assessment can only assess the present risk, which are the risks that are imminent today. Near future challenges, which are risks that can appear in near future, assuming current technology, or long-term challenges where we assess risk and challenges in the longer run, assuming if the technology will be more advanced, what will happen. And the choice of time scale also has an impact on the definition of ethical maintenance. And that ends the setup phase. So we defined the scope, we defined what is under IP, we build the team, and we also define the time scale. Next, we start the assess phase. And there we start by analyzing socio-technical scenarios of the AI. So basically what we do is we create the socio-technical scenario and we analyze them by describing what are the aims of the AI systems, what are the actors and their expectation and interaction with the system, the process where the AI system is used, and the technology involved as well as its context. And this requires several iterations among the team of experts, and this also creates a concept building process. Note that these experts are from different disciplines, so they do not talk in the same language per se. They don't understand the same terms. So in this process, we will come up with similar term that everyone can communicate with each other and understand each other. So the next phase after we have identified the socio-technical scenario is to identify ethical issues and tensions in those socio-technical scenarios. Here, ethical issue or tension refers to different ways where values can be in conflict. For example, accuracy versus fairness, where an accurate algorithm might be unfair to a certain population. Tension in a formal sense means tensions between pursuit of different values in technological applications rather than an abstract tension between the values themselves. We also define flag, which is an issue that needs further assessment. It needs, communication with the stakeholders, the developers, as well as the people involved in that AI deployment. And that could be technical, legal, and ethical. There is a list of example tensions that can arise in real world. This is not an exhaustive list, but this is just example. For example, accuracy versus fairness, accuracy versus explainability. For example, deep learning models are more accurate, but they are not explainable. On the other hand, naive Bayesian network might be less accurate, but more explainable. Similarly, privacy versus transparency, quality of services versus privacy, and personalization versus solidarity, and so on. So at this stage, we want to understand what are the trade-offs that are being made in the AI system and what should be the right one to make the trade-off. Then we describe the ethical issues, and we also confirm those ethical issues by discussing them with the relevant stakeholders, the developers, and then we also classify them. This is done by a selected number of members of the inspection team who are experts on ethics as well as the specific domains involved. And the goal is to reach a consensus among those experts and agree on a common definition of ethical tensions that need to be further investigated in the inspection process. Then we classify those ethical issues to a predefined catalog of tensions by first reviewing the applied ethics framework relevant to the domain. For example, healthcare has its own ethical framework, there is bioethics framework as well as financial ethics framework. And then we also ask the expert then classify those ethical issues with respect to those predefined catalog of ethical tensions and further classify them to true dilemma or dilemma in practice or false dilemma, where true dilemma means a conflict between two or more values exist, both of which an agent would ordinarily have reason to pursue, but they cannot because they are just you cannot have both. Dilemma in practice means tension exists not inherently, but due to current technological capability and constraint, could be time, dataset size, and resources available, but it can be resolved by solving those problems. False dilemma, on the other hand, is a situation where the AI builder probably have made a decision, but that's not really true. So there exists a third set of options beyond having to choose between those two important values. The next step is to map these ethical issues and flags that we have identified to the requirements of trust to the AI. And there we choose the EU guideline. Here we choose 4 ethical categories and the 7 requirements of trust to the AI. And just to remind you what those are, the 4 ethical principles were respect for human autonomy, prevention of harm, fairness, and explicability. And the 7 requirements of trust to the AI are human agency and oversight, technical robustness and safety, privacy and data governance, transparency, diversity, non-discrimination, fairness, societal and environmental well-being, and accountability. We also considered following two requirements to assess if the ecosystems respect values of Western European democracy, because these use cases are really coming from European region, and also to assess if the AI could lead to concentration of power. Now let's pause for an example, and I'll use our first use case, which is an AI for predicting cardiovascular risk. This is considered as a non-invasive AI medical device that use machine learning to analyze sensor data, which are electrical signal of the heart of patients to predict the risk of cardiovascular risk. It transforms raw data into features that better represent the predictive task, and then it maps the input features to output prediction with several neural networks that are then combined using AdaBoost ensemble classifier. The output of the network is basically an index between -1 to +1, which is a scalar function of dependent on the input, and finally it classify it to either red or green, saying whether there is an impaired myocardial perfusion or not. Here is the ML pipeline. It starts with the measurement and data collection, data annotation with ground truth and signal processing. And then feature extraction and selection happens. Then the model is trained with the annotated examples. And then testing happens in real world, where actions are taken for new patient based on the model's prediction, and then that is interpreted by an expert who could be a doctor or a nurse, and then discussed with the patient. Here is a very simplified version of socio-technical scenario or actor and actions of this system. When the AI system is used, the possible actions taken could be that the AI predicts the green, doctor agrees that his heart is good, no further action is taken, and the patient does nothing. The AI system predicts a green, the patient or the doctor do not trust the prediction. In that case, patient is asked to do more further invasive test. AI system predicts a red, which means there is some problem. Doctor agrees, but still no action is taken and patient does nothing. Or the AI system predicts a red, doctor agrees, and patient is asked to do further invasive test. As we were doing the inspection process, they, based on our suggestion, the team also added a third color, yellow, that indicates general non-specified cardiovascular health issues. So it's not sure. From the socio-technical scenario, we identified several ethical issues and mapped them to the requirements of trustworthy AI. As I said, I was describing about the process before. And here is one such example of ethical issue that we identified for this medical device. The data that is used to optimize the ML predictive model is coming from 3 hospitals located in the same geographical region. And there is no background information on the difference of ethnicity of the patients. And thus, there is a risk that the ML prediction will be biased toward the certain population segment that visit that hospital regularly. So if we want to map it to the 4 ethical pillar, it falls under fairness criteria. And if we map it to the 7 requirements of trustworthy AI, it falls under diversity, non-discrimination, and fairness. And under that, it's under avoidance of unfair bias. The tension here is between accuracy versus fairness. Although it was accurate for that particular segment of population, it is not accurate for population, say, in Africa. So accuracy versus fairness means that an algorithm which is most accurate for, on average, for a particular segment of the population might discriminate against other specific minority. And it's a practical dilemma. It can be removed by training the model with more data with representative data set. Now let's get back to the assessment process. After we map the socio-technical scenario and ethical issues to the requirements of trustworthy AI, we execute what it means is that at this point, we will verify different claims made by the AI systems or developers, and we verify fairness, purpose of the AI system. We question the AI design, the hyperparameters, how the learning is done, the sources of learning, feature engineering, interpretability of the model, production readiness of the model, and whether they are dynamically calibrating the model and whether they have any system established to do the maintenance of the model. And based on the verification process, we also give feedback to the team. So the verification process can be considered as if we are executing a path, where a path is created for investigating a subset of the ethical issues and flags. A path describes the dynamic of the inspection. It is different case by case basis. Parts of the path can be executed by different teams with special expertise, and the execution can be performed in a variety of ways. For example, via workshops, interviews, checking and running questionnaires and checklists, applying different software tools like explainability tools, and measuring different values and verifying those. And following the path, the inspection, we note them down in our protocol or log document, and following the path, the inspection can be traced back or reproduced again if needed. To the execution of the path, we create evidence base. And this is really an iterative process among the experts with different skill and background to understand the technological capabilities and limitations, and also to understand the perspective of different members of the society, the perspective of the users, as well as other experts. And through the process, we build stronger evidence base of the current usage and impacts of the AI. Now let's pause for an example. To verify fairness of the model that we were inspecting, we first need to clarify what kind of algorithmic fairness we want, what kind of fairness is most important for the domain, and also identify gap between different concepts, because there are domain-specific fairness metric, there are also machine learning specific fairness metric, and there are also context-relevant ethical values that we need to weigh in. And then we need to choose the fairness criteria based on the domain. For healthcare, one possible approach is to use distributive justice, which comes from philosophy and social sciences. And here they have fairness criteria could be equal outcomes, equal performance, or equal allocation, where equal patient outcome means that the assurance that the protected group will have equal benefit in terms of patient outcomes from the deployment of the machine learning model. Equal performance means that the model is equally accurate for patients in the protected group as well as non-protected group. Equal allocation means the resources are proportionately allocated to patients in protected group. This is also known as demographic parity. Now, to verify fairness criteria, we need to have access to the machine learning model. Next step is to map this domain specific fairness criteria with the ML specific fairness criteria. So for example, in ML, we have specificity and sensitivity and other kind of fairness criteria. For example, equalized odd, equal allocation, which is same as the demographic parity that I have shown in the prior slide. So we have to align them and come up with common terms. And there are also fairness criteria which are not compatible with each other. We also need to identify them and avoid those. For example, equal positive and negative predictive value is not compatible with equalized odds. Equalized odds is not compatible with equal allocation. Equal allocation is not compatible with equal positive and negative predictive value. So what type of fairness is appropriate for a given application and what level of it is satisfactory, whether 80% accuracy, 80% specificity is good enough for an application or not, that really needs not only machine learning specialists, but also clinical and ethical reasoning for case of a medical device, like the tool that we have analyzed here. So here is an example of a path that we executed. And in this path, we analyzed accuracy, bias, fairness, and discrimination. It considers unfair bias, avoidance, accessibility, universal design, and stakeholder participation as well. And this is the evidence base that we created through the execution of the path, that for the data set that is used by this particular AI, a correlation with the age was identified. The analysis of the data used for training indicates that there are more positive cases in certain age range than others, and therefore this is probably the reason behind the bias of the age. We also saw that there is higher accuracy prediction value for male than female patients, because the data set is also biased in having more male cases than female positive cases, and that could be the reason. The size of the dataset for training and testing is also small. It was below 1,000, and it was not well balanced with respect to gender, age, or unknown ethnicity. This may increase the bias effect mentioned above. And finally, the sensitivity was discovered to be lower than specificity of the AI model, which means it will not always detect positive cases of heart attack risk, which can be detrimental to the patient. The feedback, and here is a simplified version that we came up with, is that we found that the accuracy, sensitivity, and specificity deviate in part strongly from what was published by the AI developers. And there was not significant medical evidence to support their claim that the device is accurate for all gender and all ethnicity. This poses a risk of non-accurate prediction when using the device with patients with various ethnicities. And there is also no clear explanation on how the model is being medically validated when changed, because they were changing their model regularly with new data. And it was not mentioned how they're validating the accuracy and other measurement. So it was not clear how the accuracy of the performance of the updated model would compare with previous model. So that ends the assess phase. The next phase is the resolve phase, where we address ethical tensions, resolve when possible, and give recommendations to the relevant stakeholders. So at this point, we can assign a score or level to the assessed AI. That's optional. We give recommendation. We also try to help the AI vendors to resolve and address some of the tensions. We can also help them to make trade-off decisions based on analysis. And at this point, ethical maintenance can start. And here is an example of sample recommendation that we gave to the AI medical device vendor, that they should continuously evaluate the metric with automated alert when the accuracy falls below a certain range. They should get a notification. They should consider a formal clinical trial design to assess patient outcome. They should periodically collect feedbacks from the clinician and the patient. An evaluation protocol should be established and clearly explained to the users. And there is no explanation of their results, so they should try to produce feature importance of the decision and communicate that with the doctor to explain why the machine took a certain decision and why not. Now, one of the possible unwanted side effect of this kind of inspection is that assessing the ethics of AI may end up assessing ethical inspection of the entire context of the AI, and that might give rise to some issues and resistance. That's sort of what I wanted to say. I hope you have some understanding of what trusted the AI is and how to assess what are the different phases that you should consider. We have, you can find more about the assessment process as well as some of the implication that we have, or some of the results we have come up with 3 of the use cases. They are all public right now, and they're a journal paper for that. And you can also visit the xinspection.org to learn more. Yeah, that's it. So the take-home message I would say is that inspection and auditing is needed, and it needs multidisciplinary experts to understand whether an AI is trustworthy or not. Auditing process can also follow the definition of trustworthiness based on the context or domain. So for Indian government, it could be different than European Union. You can change it based on your need. We also need to consider the entire ecosystem. and socio-technical scenario. And the inspection is one such example that can evolve based on your need. So that's it. I'd like to take any question that you might have.
Thank you. Thank you, Dr. Jasmine. Thank you so much. In fact,
नेट चालू है?
very grateful to you. You have. क्या हुआ था? May I request all the participants to mute their microphones? May I request all the participants to mute their microphones, please? Thank you. Dr. Jasmine, we are very grateful to you. In fact, you have taken out time. It is almost midnight in the US, but still, I mean, you have accepted our invitation to give a talk. It was, I mean, it was really awesome listening to you. And I also thank Mr. Kishore Balaji from Intel for arranging this talk from you. Thank you, Mr. Kishore. Ma'am, in fact, you have covered various aspects like requirements of a trustworthy AI, inspection and auditing, third-party auditing, and the attributes of AI, socio-technical scenarios in the AI. And to sum it up, you have beautifully explained through an illustration case study AI for predicting cardiovascular risk. So thank you once again. My dear participants, if you have any questions related to this session, please ask, because Dr. Jasmine may not be with us till the end of the complete session due to the timing difference between India and US. So if you have any doubts regarding this particular session, the participants are welcome to ask, please. Avinash?
Yes.
Avinash, you wanted to ask something?
Yeah, I have one doubt, one question, like Madam mentioned about some metrics which can be used to determine whether the model is fair or not. So I was having the doubt that whether we should use these metrics for the training data set or for the trained model itself or for both.
For both.
Okay, like, but in a practical scenario, we don't have access to the training data set. In that case, how can we proceed?
So there are, if you don't have access to the training data set, you can test the black box model. There are tools available, open source tools that allows you to test a black box model with new inputs, and you can use those tools. So there are, if you search Google, you will find there are tools that allows you to create sort of white box model from black box model, and you can use new inputs to test whether in that scenario, when you don't have the training data available, you can use new data set, new test data set to test the claimed, specificity and sensitivity and accuracy.
Thank you. Thank you.
Thank you.
Madam.
Yes.
This is Ramaraj, Telecom Engineering Center. We have basic doubt is to design any model for machine learning or AI. What you have said, the principle is a fairness. It is also as good. Precision also is very much important. We were taught in the college days, and because how much you are accurately produce the results in repetitive task on same task. So does it not have importance here? The when precisionness of the any task.
Precision and recall is, you compute those based on false positive and true positive. So those are different metrics. You can use them. That's fine. But you need to consider what is more important for the domain involved. So as I was trying to say is that in healthcare, they have some definition of fairness. And you need to map machine learning fairness criteria with their definition of fairness, which one maps closely, and then you need to choose that fairness criteria. In case of bioethics, they could have a different criteria of fairness. So based on the application and domain you are considering, you need to choose that fairness criteria. And also for certain application, probably 99% accuracy is needed, say in healthcare. For other domain, probably 80% accuracy is good enough. Even in healthcare, probably negative specificity can be higher than the sensitivity based on the harm that one will have versus the other. So all needs to be considered. Like, is it more harmful to say someone healthy who is not healthy, or is it more harmful to say someone unhealthy who is healthy? So which one is more important? And based on that, you can compromise one versus the other.
I meant to say same, madam. The whatever you say statement, the parameter which you are choosing the parameter, that should be on repetitive further should be remained same within the limits. That indicates the stand how long stand on the fairness.
Yeah, I couldn't hear the entire thing that you said, but I think what I was trying to communicate is that machine learning metric, we need to map that to the domain metric first before we choose that metric to define the efficacy of the model.
Here, one of this parameter is indicates how much efficacy of the system.
Mm-hmm.
So this should have been one of the important parameters inside. Maybe not be explicitly to be mentioned here. Maybe probably the inside.
Yeah, I mean, the slide does not contain exhaustive list, right? It's just a sample. So yeah, there could be many other metrics that people are using for machine learning.
ये इनका था ये आता है 24/11 अप्लाई किया था 2020 में उसका अपडेटेड शेयर किया ये मतलब
धन्यवाद मैडम
मैं आपको ये भेज रहा हूँ मैं जब तक वो आपको डी वाला बनाया ये भी ले जाओ अच्छा ये भी ले जाओ डी आप दोनों करके जब तक नोट अच्छा चलो ये छोड़ जाओ आप वो करो
May I request everyone to kindly mute their microphones except for the person who is raising the query and for the, except for the guest speaker. All others kindly mute your microphones, please.
Any other question?
Please. Okay. Thank you, Dr. Jasmine. So we have come to the end of this first session in the technical session. So thank you very much for sparing time. Although you are, you are based in US and it is quite an odd time. We all know that, but still you have spared your time. We would love if you can continue with the with the other sessions also, but it is up to you as per your convenience. If you want to continue, please continue as per your convenience. Thank you very much, Dr. Jasmine. So we
Thank
now
you so much.
go to the next session. That is from our next speaker is Shri Jairam Beladekare. So he's from Ericsson, Bangalore, and I'll just give a small brief introduction about Shri Jairam. So he leads technical product management function in Ericsson Global AI Accelerometer in India. He is responsible for building AI, ML solutions for the different businesses, groups and marketing selling units of Ericsson. His work covers all parts of mobile operators life cycle, design, rollout, optimization and service assurance. He is leading the global and strategic industrialization initiative to drive company-wide maturity for supporting at-scale deployments and life-cycle operations of AI-based solutions. These engagements have provided him valuable insights on optimally leveraging AI/ML technologies in the telecom domain and practical considerations in taking them to production deployments. He is an alumnus of University of Massachusetts, XLRI Jamshedpur, IISc, Indian Institute of Science, Bangalore, and lastly, University of Mysore. So over to you, Shri Jairam.
Thank you for the kind introduction, and I also appreciate this opportunity to talk about AI in the telecom industry. So let me start off by sharing my slides. I hope that you are able to see them. So from an agenda perspective, we look forward to covering two areas. One, the need for artificial intelligence kinds of technology in the telecom industry. What are the business drivers which are motivating these considerations? Then we touch upon how Ericsson is adapting its own portfolio and evolving its portfolio to satisfy the emerging needs. And finally, in that part, we also pick up a set of representative use cases that we have worked on. These are mostly in production deployments today. So I will talk about a few of those use cases. After that first segment, we go to the second part, which talks about the challenges that one faces in adopting artificial intelligence kinds of solutions in any industry. And we show how this is just as important to our domain, the telecom domain. We heard from Dr. Jasmine Sisi about the need for ethical considerations. So in here, we talk about how do you really attempt to build trust. She referred to the guidelines that are available from the European Commission. I will quickly touch upon some of the points that are raised from such considerations, the ethical principles and requirements. Finally, how do you bring them into practice in the way that Ericsson builds its products, services, and solutions and delivers them to market? So that is going to be the scope of what I'm going to cover today. So first, I think let us look at the motivating factors. On the x-axis here, you are able to see the march of technology, mobile technologies, 2G, 3G, 4G, 5G, and in future we will also have 6G. And on the y-axis, you see the operational complexity being represented. Operational complexity normally gets converted to operational expenses as well. So with more and more services that are leveraging the telecom network now, whether it is about mission critical applications, whether it is about IoT, whether it is about real time use cases that are built on top of 5G. So one dimension. The second one is the disaggregation of the infrastructure itself. You have, with the advent of 5G, RAN parts that are separated out. You may have a radio unit, the control unit, the digital unit. You may have front haul, mid haul, back haul kinds of considerations on the RAN side. When you come to the core side, you have already seen this journey of software-defined networking and network function virtualization, which are distributing the nodes, 4G and 5G nodes, on a virtualized or containerized infrastructure, and that itself is bringing a range of complexity. And in addition to this, I referred to the new verticals, whether it is related to IoT or some of the private networks, real-time use cases, those. And overlaid on top of all of this will be this customer experience management. We need to really talk about, how do you really support a range of services using functions such as, network slicing that are being talked about. So when you consider all of them, you see that curve that is shifting up in northbound, and that is unsustainable to the telecom operators. So they already are challenged from a business case perspective. The cost of building and operating these networks is quite high, and they need to really bend that curve down to a manageable level so that they have a viable business model. And automation and artificial intelligence are core tools or capabilities that these operators are counting on to bend that curve back and make good business out of their huge investments that they have already made. So with this in mind, one needs to consider, what it means to bring in AI/ML to the entire network. And as you are able to see here, the point to note is that it is not like only certain part of the telecom infrastructure is touched by AI and automation. And we have shown at the top here, this half brain and half computer is the AI technology that one could be leveraging, and it touches the entire stack, whether you are talking about the customer angle, billing, charging kinds of systems, including customer engagements kinds of capabilities that you may be having here. Whether it is about network management and orchestration that one needs to consider. This could be the automation functionality that's available. It could be self-organizing network kinds of considerations. And how do you really manage the complexity of the network through an efficient and capable management layer? And you probably have heard terminology, and I'm going to talk about this in a little bit in my presentation, intent-based networking. So how do you make that come to fruition? That is also a consideration in the management and orchestration layer. Then the infrastructure layer itself, where you have 4G and 5G radio access, very important. I already touched upon the separation of different parts of the infrastructure, the disaggregation that is taking place on the RAN side, or corresponding to the RAN, you also have the transport evolving now, front haul, mid haul, back haul kinds of topologies that are coming up, the demands that are placed on them, given the new kinds of use cases that are supported on these infrastructures. Then you have the cloud infrastructure itself, which is virtualized and containerized. You have communication services running on top of them. You have the packet core kinds of services running on top of them. So that is shown here. And touching all of these pieces, Ericsson also has a large business in network services. Network services is about network design, it is about network rollout, network optimization, or it is about operational considerations and assurance considerations. It could be on the RAN side, or it could be on the IT and core part of the network. So as you are able to see this, we look at AI and ML touching the entire portfolio that Ericsson has. And on the left side, you see now a range of users of this, whether it is the mobile device, it's a connected car, whether it is some machine. And on the right side, it could be the vendors that are offering content or the control functionality and value-added capabilities that are making the left side devices more useful to their respective users. So this is the way we see Ericsson evolving and transforming its own portfolio with the adoption of AI/ML. With that, the business considerations that I guess one needs to focus on. There are 4 areas, as you are able to see here. One that drives efficiency, whether it is on the capital expenditure side or whether it's on the operational expenditure side. That could be one of the customers or operators' needs. Second one, more and more diverse use cases are leveraging these infrastructures. So the end user experience matters a lot. And there is great emphasis today in making the networks more adaptable, more agile, in offering the best experience as newer and newer solutions and use cases, over the top kinds of use cases are being offered by content providers. Third one needs to think in terms of how do you evolve what has classically been a very node-centric or an infrastructure-centric way of looking at the network to a user-centric way. So do not look at it as just a set of components that are stitched together, but really look at how the entire end-to-end architecture hangs together in supporting a range of use cases, which may have entirely different set of expectations from the network. Some of them could be best effort, some of them could be real time, some of them may have huge bandwidth demand, some of them may have very little bandwidth in terms of demand, some of them may be more bidirectional, some of them may be more unidirectional, and so on and so forth. Finally, I think, needless to say, with the advent of 5G and IoT, newer and newer use cases are also being brought about. And these are what could be the differentiators for operators as they march on to evolve their own networks. So with this, what we are looking to do is to empower the people and machines. So convert from an engineered network to a learning network. And we will come to this in the form of use cases later on. So it cannot be like a set of reactive steps that one constantly keeps taking. Can I be more active in the steps that I am taking? Can I have more predictive capabilities? Can I have superior root cause identification capabilities so that my downtime is minimized, etc.? So our intention is always to adopt and integrate and automation in such a way that it empowers our portfolio and services with the objective of making the switch to 5G easy for our operator customers. So the foundations that Ericsson obviously has in making this happen, we are a well-entrenched and well-related player in the industry. So we have connections to the players, and data is a key source for ML. So we have access to that data, and we have technology leadership, whether it is in the product space or whether it is in the AI/ML space. Ericsson has been working on artificial intelligence and machine learning kinds of technologies for more than 15 years now, and customizing it to the telecom AI domain. Then we also are talking about the trust framework. We heard again in our opening technical segment about the importance of trustworthiness, and that is super important in our industry. While we may talk about intent-based networking, closed loop automation and such, in a lot of use cases today, very much we have human in the loop, and we expect that to probably be the mode of operations for some more time to come until there is higher level of comfort with some of these technologies with the users. So with that, I will walk you through the uses of AI/ML in different parts of a mobile operator's business. So the first part, clearly, I think a very important part, look at the RAN. I think with 5G, energy efficiency is a very important consideration that one has. So how do you optimize the use of the radio infrastructure for minimizing energy usage and maximizing user experience? That's one part. Managing the load and the mobility across the RAN is a very important consideration. So there are use cases that we have today that address that part. Radio resource optimization, integrated access and backhaul kinds of topologies that one could be considering. Using 4G and 5G together. The parameters that come up in, for example, the design of a 5G network in itself are so large that you will leverage AI/ML for network build out. So that is another set of use cases. With the disaggregation of the RAN now, you have transport also playing a more and more important role in different parts, connecting the RU to CU to DU, and how do you really handle the traffic effectively all the way from the end user device up to the data center and integrate the management of the transport with the way you are also managing the radio resource. It's a very important consideration. So transport optimization is another area that we have use cases in. Second is core network and data centers. So in here, I refer to the journey that our industry has been through, virtualization and containerization, moving from appliances and bespoke nodes that implemented communication services and packet core kinds of functions to more of distributed architectures, where you have cloud native designs that are running on a completely virtual infrastructure. So service level management, making sure that the service KPI and the network KPIs are satisfactorily met, is a very important consideration here. So system availability and robustness is important. When you have such shared infrastructure, how do you optimally manage that? How do you do proper forecasting so that you manage the business objectives on the services side as well as the cost side? So that's resource optimization is important consideration. We are seeing more and more need for incident detection and resolution. It is more complex to manage a distributed architecture running on a virtualized infrastructure. So how do you really do the triaging properly? How do you lead the front office teams and the back office teams in the direction of quick resolution? How do you bring the infrastructure back into service as quickly as possible? A lot of the cost actually is incurred in handling trouble tickets today, and how do you minimize that? That is another dimension. Network planning and optimization. This, as we are looking to build in 5G on top of 4G. How do you really do proper planning and design? We have seen use cases today, for example, computer vision based use cases that are helping us position the 5G infrastructure properly. This I'm referring to primarily to the advanced economies, North America, for example, vision based use cases to take geographic information and understand how best to build out the 5G on top of your existing tower infrastructure. How do you do proper planning and design? I already referred to this, the need to optimize a wide range of parameters. AI is being used there. How do you optimize customer experience? We have had use cases. One interesting use case was, could one look at traffic congestion, vehicular traffic congestion, and when you are stuck in traffic, it's likely that more people are using the radio network in that congested part of the roadway. And how do you adaptively organize your radio network to improve the customer experience under such conditions, which, when you do that, you may be consuming more power, but you are maximizing customer experience. And when that congestion goes away, you can back off of that. So such use cases we have worked on. I already referred to, ticket handling and resolution, work orders where it may require you to do so tower climb or whatever. So are you able to, for example, a priori inform somebody that, this is the component that you should be looking at? So the downtime is minimized. Also, the truck rolls are more optimized and minimized. Finally, the new use cases related to IoT and analytics related to IoT, device and connectivity for some of these machine type communication use cases. Needless to say, the advent of these use cases, whether it is about enhanced mobile broadband or the kinds of machine type use cases we are talking about, security, all pervasive security is super important. And how do you leverage AI/ML in making sure that your infrastructure is stable, it is operating as expected, and you are able to isolate the security threats to parts of the infrastructure that minimize the impact of any downtime or poor SLA to only a smaller part of the infrastructure. So these are all use cases that come to mind. In all of these, one can leverage artificial intelligence and machine learning. So with that, I'm going to jump to the second part of my presentation, and you will necessarily find that parts of this overlap with what you heard from Dr. Tithi earlier. So let us have a quick business perspective initially. What I am showing you here is based on an Ericsson Industry Lab report that was published recently. It spoke to a wide range of business stakeholders who are involved in analytics and AI in different organizations across industry segments, as you are able to see on the right side. These folks told us about their view of where AI adoption is, whether it is in a leadership position, whether it is in a sort of a follower role, or it is just in an early stage. And you are able to find that in our industry, IT, information technology and technology products, I guess not surprisingly, the adoption is the highest and the most number of players in the leadership part of the bucket. And then you can go down and see that, in some of the other industries more related to process and manufacturing, fewer industries have taken those steps. Now, the reason to show this is even in this kind of aggressive push for AI and ML, there are core challenges that companies face. They are of three different types. Technology-related challenges. Technology-related challenges could be, for example, the technology could be too complex or not available. The technology may require specific hardware and software. So those are the kinds of technology-related challenges one may find. A second one may be the lack of skilled employees that are well versed with AI/ML. So that and the structure in the organization itself to drive AI/ML kinds of business proposals for those are organizational challenges. And third one relates to people and culture. And people and culture questions of the following type. Employees may be comfortable with their tried and tested legacy ways of doing things. They may be concerned about job losses if these technologies take over what they have been doing and where their own specialization lies. They may be unwilling to change with the evolution that we are talking about. They may not be able to understand the technology. They may feel like they are going to be not in control. And you can find that our survey showed that very large percentage of organizations face this as their front and center issue. It's technology challenges and organization challenges do exist, but people and culture, sometimes we overlook them, but they are critical for success. Most organizations responding to the survey said that these are important, and in fact, it was the area of focus for a large number of them, driving strategies for addressing issues related to people and culture. All of this leads you to appreciate the critical importance of getting humans to trust AI. And that is going to be the focus of the rest of what I'm going to touch about. So we again, in the previous presentation, we got a good overview. Let us look at the basis of trust. On the right side, I have a reference to Charles Green's trust equation, credibility, reliability, and intimacy. In the numerator, the higher the credibility is, the higher the reliability is, the higher the intimacy is, the better trust is. and self-orientation is my interest about myself, or am I aligned with your interest? So that equation is central to understand, and that this trust equation that I am showing here is not specific to AIML. It's a broader human nature related perspective of trust, but that just as well applies to AIML. And with that in mind, we need to answer questions. I think we heard from the previous presenter a little bit about explainability, questions like, but why? Can you give me details and the underlying reasons of what you are finding? Then second kind of questions will be, are safety mechanisms and humans oversight built in already? Could the solutions that we have implemented, the agents that are part of the end-to-end architecture, could they do something either maliciously or inadvertently that could cause harm? How do we avoid that? How do we give the confidence that the solution is robust and stable? There are specific technical definitions to stability and robustness. I'm not going to spend a lot of time, but in the next slide, you will find this is going to be the 7 requirements that we heard about from this European Commission ethics guidelines. There is a set of definitions around robustness and stability. One needs to keep those in mind. Finally, privacy is super important. How do I ensure that data that has been used by these solutions is not used in a way that is not intended? When we say not intended, it is only used for permitted purposes. Secondly, there should not be leakage of data, either through, for example, some people have attempted to do re-engineering of models if you have exposed your models through APIs. So how do you really do model obfuscation? How do you protect your models? There are a range of considerations related to privacy. So these are all extremely important. Given this, I just want to refer back to this and draw your attention to this. We heard about each of these items in our previous presentation. So these are the 7 requirements that we have come across, and these address the ethical principles that we again heard about. Respect for human autonomy, prevention of harm, fairness, and explicability or explainability. So considerations such as human agency and oversight, technical robustness and safety, privacy and governance, transparency, non-discrimination and fairness, diversity, societal and environmental well-being, and accountability. They are all extremely important. And in the way Ericsson has adopted AIML into its product, services, and solutions, these form the bedrock of how we look at AIML. And these have been integrated into something that we call as generic product requirements, or GPRs, and we check our AIML capabilities against these considerations. So a little bit about that. How do we approach this? Again, the trustworthiness, we heard about the 3 considerations about being lawful, about being ethical, and about being robust. Robustness from a technical perspective, as well as from a societal and environmental perspective. So both of them are important. Given these, we have an approach of end-to-end perspective when we look at AIML. When I say end-to-end, I am talking about all the way from data coming in from the network or from the consumers, whatever data that may be coming in. So how that data is coming in, what are we doing with that data? So these are security related to data, access control on the data, data validation, and data quality check, anonymizing the data. If we are using any private information, explicitly seeking consent for that specific objective. Considerations such as separating training data from test data. So these are all important in our architectures. Secondly, once you have the input data, we need to now talk about the algorithms and related technologies. Algorithms could be machine learning kinds of algorithms. They could be machine reasoning kinds of algorithms. So considerations related to auditability, transparency, protecting the code itself, protecting the model parameters when it is deployed, so that there is no scope for poisoning or compromise. Another important considerations. Drift is a critical consideration in industrializing AML solutions. Just because you have a solution that works well in a lab setup or on small quantities of data or even large quantities of data in a particular installation doesn't mean that it will work across other installations or it will work down the line. So one needs to constantly monitor the performance of these solutions on the data side as well as on the concept side. Then issues related to model output, the inferencing that you are performing and how that is being consumed. A lot of the times, the inferences that come out of these models are not directly used. It may be fed to a set of business processes or business logic. So how do you really, again, consider issues such as security and access control so that there is no compromise on that side? If personally identifiable information is being used, how do you de-identify those? And if actions are being proposed, how do you explain them? And if, again, if steps are being proposed, getting consent from the impacted party about that action. So all of these are extremely important considerations. And for reference, I have included some Ericsson as well as some public documents here. So with that, I want to now give you a very concrete example. We talked about the considerations related to ethics, trustworthiness. So in a practical telecom network, what does this all mean? Is a question to consider. Let us just take this example in explainability. So what I am showing you here, think of this as let's say a 5G network slicing example, where you have video streaming on a network slice, which is supporting, say, video type of traffic, and you are expecting the network to adopt and give a desirable level of service level to this particular traffic. And what you have in this particular case is a predictor which is predicting the traffic. After that is done, there is a node here, another AI node, which is using the predicted information to see whether the higher traffic load as predicted could cause any SLA violations based on some congestion points in the slice in the infrastructure. So that's the second part. Third one, once you know that, there are optimization steps, reconfiguration steps that one could take in rerouting the traffic as necessary, reconfiguration of the network nodes using automation. That is the third part of the AI. So the reason I am giving you this example is I will show you now ML models that are predicting networks traffic. Now we have a rule-based system here, which is using domain knowledge for figuring out incipient congestion given the predictions of ML. Third one is a set of constraint solvers which can help you reconfigure the network to divert traffic. So if you get this now, would you let the system work on its own? Maybe not. So we need to enable the users of this AI solution. We need to empower them with explanations such as, why am I making a prediction of increased traffic? What are the features that I am using? So once you give such ML model explainers, it helps the administrator, the operations technician, to know whether it makes sense or not. Some responses back and forth that the system can offer to justify the reasons for that prediction. Secondly, once you say there is going to be congestion, how do you explain that? Rule tracing explanations could be leveraged. Again, this is an example, keep that in mind. We have, in fact, shown a proof of concept around this. So facts and domain knowledge, how do you bring them together to help infer the root cause that, this port on this router is expected to be congested if this is the traffic. Third one, now you have offered an alternative. One may want to know, why did you recommend that? So contrastive explanations could be called for. What were other alternatives that were looked at? What were their consequences? Vis-a-vis all of those, why was this recommended, could help understand the reasons for making this rerouting recommendation. And so through explainability, very important part of trustworthiness, we are showing you how explainability applies in different ways to different parts of the AI solution here. One is an ML model explainer, one is a rule tracing explainer, a third one is a contrastive explainer. So these are different technical approaches that one could use to offer details to the human operator or the user of this solution. So with that, I will take a step back now and give you an overview of what we have. This is a broader framework that Ericsson has in an end-to-end value flow, all the way from our suppliers, whether it is component suppliers, hardware suppliers, or software suppliers, to our customers, our operator customers. So we have functions such as sourcing, research and development kind of function, and then manufacturing and delivery. So across all of them, we have our security reliability model, which is the foundation on which we implement end-to-end value guarantee. So there are functions, as you are able to see, there are the 4 boxes. Purple box talks about the functions that are implemented in a solution. Second one, steps that are used in the assurance phase. Assurance is once you have delivered, what are you doing with it? That's the part. The third one that we are talking about here, how do we inform our users about compliance and documentation? And fourth one, in actual deployment and operations, how are we ensuring that things are getting done as expected? With these in mind, I want to show you a few points in the functional area where product security and privacy ambitions for our products and solutions. Sorry about the flight overhead. So in here, for example, we have implemented generic requirements on product, service, and solution security and privacy. And we undertake risk and privacy impact assessments specifically. Secondly, in the assurance phase, we run our solutions in the target environment. And in that target environment, we again do risk assessment, privacy impact assessment. We look at considerations such as secure coding, vulnerability management. This is about risks that one could see in, for example, open source software and related technologies. And then hardening. How do you make sure that things are robust and hardened? In compliance and documentation, we empower the users of our product, services, and solutions with certificates and statement of compliance. And we also issue maintenance guidelines. In the deployment and operations, these are people that could be taking up system integration, securing end-to-end operations, and then, in spite of all of this, you may have incidents related to security. So how do you address them? So reason I am showing you this is this security reliability model is just as applicable to what Ericsson creates for its Eiml solutions, not just its traditional hardware and software products. So we use the same base framework, security reliability model for our Eiml solutions, which augments some of the trustworthiness considerations that I showed you previously. With that, I want to quickly show you our, you probably are familiar with our Ericsson operations engine. This is the platform, if you will, that helps operators manage complex networks. As more and more devices connect to the network, more and more traffic volume is handled, and more diverse services are supported by them. So you can see the outermost circle here, are the considerations or the business outcomes that operators have. It could be transforming technology, 4G to 5G, physical to virtual, and cloud native and such. Optimization of costs, capital costs, operational costs, new revenue streams, improving customer experience, agility, and faster service creation. And how do you really ensure security and empower trusted business? So with those, what you need to understand are a set of capabilities that need to come in, like, for example, smart design or an ability to deploy in a very dynamic way. We keep hearing about data-driven operations, intent-driven networking, etc. Intelligent optimization. I talked about a number of use cases one can consider here. End-to-end security that is seamless, agile application management, and collaboration. In some of these new use cases, it's not like the telecom network itself is a platform which empowers value creation on top of it. So how do we really create a network that enables collaboration and innovative solutions to be created on top? And within this, the foundation for all of this are the components that you are able to see here. Artificial intelligence, automation, and data, extremely important, but one cannot forget. I already referred to the challenges in organizational side and people and culture. So very important. So you need to have proper retraining of people, adapting your processes to really leverage some of these new and emerging technologies properly, and a way to have proper interfaces and APIs for you to leverage the full value of the complete stack. So that, I think, closes my presentation. I do have a set of references at the end of it, which some of these that you are finding here are all documents, reports, guidelines that have come from industry regulators, governments, etc. Whereas the last slide that I have here on references, it is a set of references from Ericsson itself, the white papers and blogs that we have published on trustworthiness and its applicability to telecom. So I stop there, and thank you again for the opportunity to tell you a bit about artificial intelligence and machine learning in the telecom infrastructure, how it is transforming our industry, and Hello? Are you able to hear me?
Yeah. Now we are able to hear you. There was some pause in between. Last 1 minute. Okay, please go ahead.
No, I am done. Back to you.
Okay, thank you, Mr. Jairam. That was simply an awful presentation. You have covered various aspects. I mean, from Ericsson's point of view, you have covered AI and automation use cases. And how ethics framework and the example on explainability, it was superb. Thank you, and I also thank Mr. Subrata Kumar Mitra from Ericsson Bangalore for arranging such a wonderful speaker. Thank you, Mr. Jairam. So please, I request you to please be there till the end of the session. We have one more speaker, that is the last speaker, and thereafter we take the question and answers. So, Mr. Jairam, I request you to be there.
I will do that. Thank you.
My dear participants, our next speaker is Mr. Snehanshu, and he will be covering the topic of green AI. And I'll just give a brief of Mr. Snehanshu. He leads the AI initiatives at NASSCOM. He also heads the COEs for data science and artificial intelligence. He is responsible for creating, nurturing, and scaling up a vibrant AI ecosystem that involves driving AI adoption. Working, conducting applied research, creating multinationals, GCCs, and startups across sectors such as technology, telecom, hospitality, retail, and banking. So prior to joining NASSCOM, Mr. Snehanshu has been a part of Vodafone Shared Services, Zyme, Dell Global Analytics,
Thank you so much. Can you hear me, everybody? I just want to do a quick check if I'm visible and audible to everybody.
Yes.
Wonderful, wonderful. Thank you so much for the kind introduction. Okay, well, so there seems to be a little bit of a network issue, and in the event that I am not audible, please do put it in the chat. I'll try and search for an alternate.
It's okay. It's okay.
Okay, lovely. So thanks for the opportunity.
Okay, please go ahead.
Sure. So thanks for the opportunity. I think I'll try and speak on this topic on green AI that I've been asked to lend my views on. I'll try and keep my presentation short to about 20 odd minutes for two reasons. One is green AI as a topic is subsumed within the larger context of ethical and responsible build and use of AI. And speakers before me have already covered sections of what constitutes responsible and ethical use of development and usage of artificial intelligence. But more importantly, I understand that I'm probably going to be standing between you and your lunch, and I don't want to be very unpopular in trying to extend the discussion to beyond a certain point. I have a small presentation to make, not a lot of slides, but then let me know once this is visible to you. Just give me a...
Yes, visible.
Wonderful, wonderful. Thank you. So green AI is an emerging topic, and my idea of the next 15 odd minutes would be to give you a sense of all the three aspects of what, why, and how, right? I'll probably try and preface my my sort of introduction by saying that there's this very useful piece of information that Time magazine shared some time back, and they were very observant of the fact that the world around us is changing tremendously at a rapid pace. We are in the middle of a digital renaissance in many ways. It is helped in generous parts by the exponential growth in computing power. And all of this will come together to create this whole concept of technological singularity, which is essentially a point in time which people hypothesize that powerful super intelligence will be achieved. And you are in a stage where human and machines kind of work together to bring in significant changes to the human civilization. Just to reflect on this a little more, what was proposed that maybe by 2015 will surpass the brain power of a mouse, progressively moving on to doing sort of improving upon the human brain power, and by 2045 machines will probably take a lead in going beyond the combined brain power of all human beings. Now, as fascinating as it seems, there's an element of truth to it. We see that the rise in intelligent machines is definitely a trend. But the thing that I would probably draw your attention towards is this whole point around the exponential growth in computing power, where it is alleged that now, as where we stand, every hour we are processing and progressing more than what we did in the first 90 years of data capture and processing. And that's a fascinating statement. Whether we reach that concept of singularity remains to be seen, but if available indications were to be adhered to, we are definitely on that trajectory. I wanted to talk a little about the carbon emissions part of it, and this forms a precursor to the whole topic of green AI. We are seeing a tremendous increase in the computational resources. There's a 300,000 times increase in computational resources just in the last decade or so. We are doubling the rate of power consumption by AI systems every 3.5 months or so, and that is again extremely staggering a figure. But what this is also leading to is this whole situation where we are emitting a lot of carbon dioxide, emissions, and it is believed that just to tweak a certain model, which is essentially taking a off-the-shelf AI solution or an AI language processing model, and to bring about subtle changes, you are ending up creating emissions of about 1,400 pounds or so. And if we were to try and sort of do a more grounds-up effort in building it right from the scratch, that multiplies many-fold. So the whole situation presents a little bit of a conundrum. The paradoxical situation is that, are you then looking at a negative role that artificial intelligence is playing in relation to the environment? Its role in sort of identifying opportunities to reduce the emissions is very well established, but there is another side to it, and which is what researchers and academic institutions and certain organizations that are responsible are trying to sort of alert us, inform us from time to time. This whole council, which is the Iowa Climate Change Council, makes a pertinent point. They're saying that we will need to reform our AI practices, or else artificial intelligence in times to come could very well become an antagonist, and it's not going to be a friend in our fight against climate change, and that's very significant. So what is fueling the compute hunger? Maybe this is a good idea to take a step back, and there are various ways to look at this whole situation. From my perspective, there are 2 or 3 things that we need to bear in mind. One is the rate at which we are collecting data is very, very significant, and not just collecting, we're also utilizing data at a very significant rate. Some interesting sort of anecdotal information around, let us just pick up one stream, which is natural language processing. Let us just talk about this whole language models that we are seeing a craze towards. A BERT model was developed just a few years back, which used about 3 billion words, which is a humongous corpus. And then progressively from that point onwards, the subsequent iterations, either by the same company or different companies undertaking similar kind of research, you see from 3 it has jumped up to 32 billion, right? From there 40 billion, and then last year GPT-3 was released, and it uses about 500 billion words as a corpus and about 175 billion parameters, which is again mind-blowing. So data sets definitely is fueling this compute hunger. The second is, when we talk about artificial intelligence, it is intrinsically linked to what you call neural networks and deep neural networks. And this field is still evolving. We are still trying to understand how to sort of do the right amount of feature engineering, how to sort of do the hyperparameter tuning, how to identify the right kind of a design for the models. These are kind of fields and areas of study which people obviously are trying to come to terms with. And the mathematical operations that get carried out at the background require a lot of computational power. And that is another reason why we are seeing this whole drive. And the third is what I call this need to get into this domain of artificial general intelligence. Now, artificial general intelligence is one where you are trying to have certain expectations of artificial intelligence where they think across a different set of operations, much the same way that a human mind would sort of think about. So it's not really particular, fixated on a certain use case or a certain domain. It's this ability to transcend those barriers and look much further beyond, right, to answer a whole range of descriptions. And then that is giving rise to this phenomenon of, bigger is better, because now it needs to be developed in a very, very different way, look at a multitude of problems and all of them adding up to a computational cost. What is green AI? With this, the background, it might be interesting to sort of understand it in 3 or 4 steps. One is at a very high level. We are looking at environmentally friendly set of practices in scientific research, very, very important. The second point is very important, that you're not only looking at the efficiency, but also the sufficiency as to how much more should I want to do towards getting those incremental results around model accuracy. So efficiency is one and sufficiency is another. How do I balance the needs of both these aspects? The third is we are not just focused or obsessed around treating efficiency as the single most important criteria. We have been talking about accuracy. So how do we bring in accuracy and efficiency together is something which is very important. I'll talk about this point a little more in one of the forthcoming sections. And very importantly, the outcome of it is going to be reflected in lower carbon footprints and help increase the whole aspect of inclusivity, where researchers are able to also contribute equally to a field where technological giants have the resources or means to contribute. So between these 3 or 4 things, we start getting a picture of what green AI is and what it could possibly do. With this in mind, the question that probably follows is, so what can organizations do, whether it is private or public organizations, institutions, academia, what can they do to drive green AI? The answer is probably not one. The answer is, doing a combination of things, whether it is to look into platforms, tools, processes, partnerships, etc. All of these put together. I'll talk about the first. Let me just give you an overview. So the theory here is that it is important for you to start measuring and reporting it. Very, very important. And how does it sort of build on your existing mechanisms? I'll try and talk about in a little while from now. It is also important for you to look at the incremental benefits of training your model on additional data. And if the benefits are significant, go ahead with that. But if it is not so, then maybe you should pause and reflect on what you're doing. The third thing is this whole point around what we call reproducibility. Reproducibility, again, is a very important aspect. And the theory here is that can we get to a stage where alongside the release of a research paper, we are also encouraging researchers to release the code, to release the models, such that developers around the world are able to not just understand the point of view, but they also have the code and models to tweak and replicate those results in a slightly different domain or to answer a different set of use cases. So reproducibility is going to be a very, very important aspect. And today that is not quite the case, and which is something that is holding back this whole drive towards green artificial intelligence. From a hardware perspective, again, it is important that we make systems energy efficient. The whole drive towards accuracy and faster speed and reduce processing times, etc., were a big consideration. But I think we are seeing some amount of innovations in this area. Very recently, you would appreciate that Google, with its TPU, is kind of taking a firm step towards making more energy efficient systems. And in time, all the major manufacturers, in our opinion, will follow suit, whether it is NVIDIA, whether it is Intel, and some of the others. It is going to be a critical step from a hardware perspective, and more innovations need to happen in trying to develop those energy efficient systems. Democratizing deep learning, I think this is a big one. It is to say that today you are sort of innovating in a certain silo. Deep learning is a complex area. So much of it is layered. There are so many nuances to it that we are still trying to make sense of. Unless we create those shared learning opportunities, we will all start, what they call sort of inventing and reinventing the wheel in our own sort of respective labs. AI truly needs to be democratized such that those learnings are shared and we are able to build our own specific solutions on the bedrock of those shared learnings. And hence, democratization of deep learning and artificial intelligence will be a big enabler in saving computation power and using it where it is absolutely necessary. The final point that can be argued is, again, on the point of democratizing deep learning, we need to work with a very robust artificial intelligence ecosystem, which comprises of academia, which comprises of research labs, which comprises of startups as well as enterprises, where they come together to solve problems rather than wanting to solve it all by their own. This will create, in our opinion, more efficiencies in the process, faster innovations, better mechanisms to fail fast and then learn from those failures, etc. This concept of learning and engaging with the ecosystem will also go a long way in driving this whole mandate for green artificial intelligence. This is a very interesting example, that we can all look at. A random sample of about 60 odd papers that were presented in various AI conferences across the world were profiled. And it's interesting to see that what kind of metrics those papers focused on. The accuracy part, which is represented in the red bar, clearly stands out. That most of those papers spoke about accuracy as an important measure of their accomplishment. And the bar in green represents the efficiency related metrics as to how efficiently those solutions were developed. And you see that it is a small fraction of the papers that were presented in the conference. And there were some others which combined both accuracy as well as efficiency metrics. Now, I use this to make a point that I was arguing about earlier, which is to say that our focus around accuracy will probably not go down, but it is also important to bring into question the whole, discussion around was this developed efficiently, and maybe the change can begin here. Maybe progressively, as responsible institutions and organizations, we say whenever there's a AI project that we are working on, I will try and report back not just accuracy but also efficiency metrics. Moving on to this same topic of measuring, and we are seeing a good amount of research happening today. and the research is the first one that I would like to sort of quickly talk about is this research paper. The first draft of it was presented last year that was led by Stanford, Facebook, AI Research, and McGill University, which talks about this whole need to report, carbon footprints of machine learning solutions. And they provide a beautiful framework on how it can be achieved, right? And what kind of empirical evidence can you supplement along with your submission. And that is a great way of sort of bringing out that message that your organization is environmentally responsible. This is a paper that we can spend a couple of hours talking about, but to the audience and to those that are curious, do a Google search on it. It's a slightly lengthy paper that dwells into various aspects of how it can be captured, how it can be made possible, what is to be washed out, how do you benchmark this reporting process, what are some of the caveats. It's a beautiful paper. And again, there are increasing number of tools that are being offered to try and gauge whether your AI solutions today are carbon compliant, how much incremental energy they are making use of and stuff like that. The whole idea is to report that computational price tag that is very, very important in today's world. The other thing that we are sort of looking at is this whole concept of being carbon negative, and it is a mechanism whereby cloud service providers are sort of selling their own services as being not just carbon neutral but carbon negative, which is where your AI processing units and the heat that is being generated by those processing units are progressively being pushed to different factories that can make use of that as a viable source of power, right? I know of this green AI cloud services provider that has a similar mechanism. So I think this is a very, very interesting way of not just counteracting the effects, but also going a step forward in using that as a viable source of power as well, and effectively becoming carbon negative, not just carbon neutral. I spoke about the diminishing marginal utility, and let me just take a couple of minutes to explain this a little more, and I think that will be about it from my side. So on the x-axis you see the data requirements that are there, and on the y-axis you will see the improvements that you are trying to bring about in terms of accuracy. Now, till a certain point, it has a sort of linear kind of a trajectory, but there comes a point where increases in the amount of data that you feed in does not have as strong a bearing on the model accuracy. And this inflection point in some ways has to be sort of referenced more carefully by AI researchers and developers and say that even if I'm able to bring in an incremental benefit to the model accuracy, at what cost am I achieving that result? And is it really viable from a sustainability perspective? And if the answer is yes, by all means, go ahead. But if the answer is no, maybe that is a good point where I would want to stop my quest to bring about further improvements to the model results. So in conclusion, 4 or 5 things that I want to talk about. I spoke about the intelligence explosion, and we are probably on our way to achieving that concept of singularity. By what time, we'll have to wait and see. We are also seeing that we are in the middle of a AI revolution, and it is being aided by data, which is coming to us at great speeds. It is also aided by computation advancements that we have seen in the recent past, but very importantly, our aspirations to be best in class in everything that we do. But the aspiration part also needs to be balanced with sustainability and the concept of responsible AI that we quite often speak about also needs to compulsorily talk about green AI. Today, it is being dissected from a point of view of inclusivity, fairness, removal of bias, being safe, being accountable, And some of those measures, green AI, so much is not being spoken of in the context of ethical and responsible AI. Maybe that is a change that we need to bring about. Creating awareness is very, very important. Measuring and reporting is very, very important. And maybe that is a good point for us to start. So from a measurement perspective, each solution that we develop should track the carbon emissions, should track the electricity usage, should limit the number of parameters that we are making use of in trying to develop a AI solution, and also report the carbon and energy emissions. We can talk about a carbon impact of the AI solutions by company. These are all good to have ideas, and maybe this is a good starting point for us to think that way, start measuring and reporting. That is very, very important. And finally, the whole concept around AI democracy can be achieved not just through improvements in processes and hardware, but also through collaborations, partnership, and sustainable innovation. So I'll rest my case today with this, and back to you for any Q&A that you may have for me. Thank you so much. Hello.
Thank you so much, Snehashuli, for the enlightening talk that you gave. So I have one question in this regard. Am I audible to you, Snehashuli?
Yes, you are.
So my question is that what I feel that the most of the energy consumption takes part during the training part of the AI solution. So unless we do the training, how do we come to know that?
Mr. Snehanshu, thank you for that wonderful presentation. AI is not complete unless we talk about green AI. It is very, very important. So thank you for that wonderful presentation. And now, we will have this question and answer session. And before that, I can see among the participants, one of the senior most ITS officer, Mr. Ashok Kumar Mittal sir. He's Director General Telecom. So, but it is showing on hold. May I request you, sir, to say a few words? Yeah, sir has joined. As I said, one of the senior most officers of DOT, Ashok Kumar Mittal sir is there. Is Director General Telecom. Sir, if you can hear me, I want to request you to say a few words, sir. Mittal sir. Yeah, sir is joining in a moment. Yeah. Welcome back, sir. Welcome back, sir. Sir, we had a wonderful session today, webinar on artificial intelligence and ethical issues. So we had three wonderful speakers from the industry. The first speaker is Dr. Jasmine. She is from United States of America and she is from Intel. And the second speaker was Mr. Jairam. He is from Ericsson in Bangalore, and third who had just finished his seminar. The webinar operated today morning by UK Srivastava sir. Sir, I would like you to say a few words.
Thank you. I am really delighted that NTIPRIT has organized webinar on artificial intelligence, which is one of the talk of the days. Although it is very old and the people are as I also logged into this webinar initially, but I had to come out of this because of engagement. But I am so happy that NTIPRIT has organized such a wonderful webinar with the experts in this field. I'm sure this will go a long way because we need to make use of all the technologies relevant to the development of the telecom and the features and utilize the features and the facilities for providing better services to the customers. So I am delighted on this and hope that this webinar would have been useful for all the participants to take further interest in AI and utilize the knowledge gained in further enriching themselves and applying that in future for the betterment of the department in providing the facilities to the customers. I thank NTIPRIT for giving me this opportunity to log into this webinar and say a few words. Thank you very much. Thank you all the participants.
Thank you so much, sir. Thank you. Thank you for the words of encouragement. These words, they give us a lot of inspiration for NTIPRIT to conduct more such webinars in the future also. Thank you, sir. Thank you. So now the floor is open for questions. So anybody having a question, please raise your hand. Or you can also unmute your mic and you can ask the question. Sir, we have another senior most officer from Himachal Pradesh LSA, Subhash Chand sir. Sir, would you like to say something? Subhash Chand sir.
Yes, thank you, Mr. Srinivas. Actually, this webinar is very useful for our ITS officers who are dealing with all telecommunication development in our country. And I hope that NTIPRIT will continue to organize series of webinars on latest technologies. And I thank all the speakers, Ms. Jasmine, Mr. Jairam and Snehanshu Mitra for their wonderful talk. Thank you all. Thank you, Mr. Srivastava and Srinivas and all team and NTIPRIT.
Thank you, sir. Thank you. Thank you, sir. I can also see Mr. L. Anantaram. Anantaram, sir, is there. Sir, would you like to say something, sir?
Yeah.
Anantaram, sir, if you can hear me.
Yeah. Thank you, Mr. Srinivas.
Would
Are you able to
like
hear
to
me?
say something, sir?
Yes. Thank you, Mr. Srinivas. Are you able to hear me?
Yes, sir. Yes,
Hello?
sir. I am able to hear you, sir.
I congratulate you for organizing such a wonderful webinar. Actually, it is very informative. The application of this AI and ML in telecom services, I think that is very important, like improving customer services, fraud detection. I'm really informed about this AI and ML, and also green AI. I am very much impressed with the talk, and I'm sure that more such webinars will be there in future, and all the participants definitely they will be benefited from this webinar, and they will apply this knowledge in improving the customer services. Thank you, Mr. Srinivas.
Thank you, sir. Thank you. In fact, just I want to inform you that every alternate Wednesdays, NTIPRIT is conducting such webinars on important topics which are concurrent and relevant. So you are most welcome to join, sir.
Yeah.
As per your convenience.
Yeah, Mr. Srinivas, last webinar on submarine cables I attended, and also based on the information I gathered, I contributed one article also to newspaper. Thank you. Definitely, I will attend such webinars in future also. Thank you.
Great, sir. Thank you, sir. Thank you. So, any questions from any of our participants?
Sir, I was asking a question from Snehanshu, so may I proceed?
Manish, yeah? Manish?
Yes, sir.
Manish, you wanted to ask something?
Yes, sir. So, am I audible, sir?
Please go ahead.
Snehanshu ji, are you there?
Yes, I am.
So, my question is, there are two related aspects of your presentation. One is that you said that the researcher should pause at the point of inflection where there is no further great improvement in accuracy with increasing data. Second, you
मनीष
said
जी
that
आपका आवाज नहीं आ रहा है.
I can follow.
let me try.
I can follow. Please carry on.
Okay. So second point is that you said that there should be some democratization where the trained model be made available to other researchers so that the energy consumption may be reduced.
Yes.
So my question is that most of the energy consumption takes place during the training. So once the model has been trained, so already the energy has been consumed. So how the energy preservation will be there? And second point, whether transfer learning will be useful in this aspect. Did you get my question?
Yeah, I'll do my best to paraphrase.
Yeah.
So you're saying that I made two arguments in my presentation. One is the whole inflection point where I mentioned that increase in data and computing does not necessarily translate into better results at the same rate. That's something. And the second thing that you spoke about was the democratization of models, which is where we share this information, the code and models with others. Your question, the first question was around, well, most of the computing resources are used up at the time of training the model. Why would subsequent iterations take up so much computation power? Well, so let me try and address that. When we talk about off-the-shelf solutions, Manishji, we are talking about kind of standardized solutions which have been developed but need to be applied in a certain domain, which would see newer forms of data, newer complications coming in, and in the model sort of trying to answer those questions directly. A very different kind of effort is needed, although you have a baseline model that is already there. To train it on the newer sort of nuances, circumstances, industry practices, plus historical events, etc., that is again an equally computationally intensive process, right? And that will again end up taking a lot of your time as well as energy, and which is where the whole point around sort of being very aware of that process came in. Really, that was the first one. I missed your second question, Manish. If you can please repeat that for me.
So there are two questions. One is that when we reach the point of inflection, when the researcher reach the point of inflection, already the energy has been consumed. So means how this energy conservation comes into play, and second, whether transfer learning will do off the shelf, or the transfer learning is the same thing, or will do will help in saving the energy.
No, so the inflection point. So the inflection point, Manishi, there will be a new one again once you're trying to retrain the model for a different purpose. It is not the same inflection point again. The point that I was making is for the same use case. If you are trying to develop a model up to a certain point, by the infusion of newer data points, you are able to improve the model accuracy exponentially. But there will come a point where for the same use case, if you are to continue to infuse more amount of data, right? Let us say more amount of historical or time series data, the returns will be diminishing. But that principle will not apply if we are to change the use case, right? In which case a new kind of sort of efficiency curve will need to be created, right? So I would suggest that let us keep these two things sort of separate. I was talking about the case where the same use case is seeing more data of the same kind being infused and expecting the model to give out improve results exponentially. That is probably not. Hope this explains.
Yeah, sure. Thank you.
Okay, are there any more questions? I see there are no more questions, so I'll take the liberty to wind up today's webinar. So before winding up, I want to thank profusely our senior DDG NTIPRIT, Sri Yukesh Srivastava sir. I mean, sir has been the driving force behind the webinar, and he has been a great source of inspiration to all of us here in NTIPRIT. Thank you, sir. I thank the three guest speakers of today, Dr. Jasmine from Intel, Mr. Jairam from Ericsson, and Mr. Snehanshu from NASCOM. So all the three guest speakers that we had today, all of them have given awful presentations, very informative and very useful. Thank you, all our guest speakers of today. I would like to thank NTIPRIT, my ICT faculty, Mr. Siddharth, Mr. Manish, and other, the training faculty of NTIPRIT, Mr. Adil Singhal and his team, and all other faculty members of NTIPRIT. And I would like to thank the people from TRAI, TEC, who have, and from the industry, telecom industry, who have joined today's webinar. I would like to profusely thank all of them. And lastly, but not the least, and most importantly, I would like to thank all the participants who have joined today's webinar. They have joined in overwhelming numbers. So I would like to say that your overwhelming support to us, it encourages us to conduct more such programs in the future. Thank you once again, and the webinar is closed. Thank you.
Thank you.
Thank you.
Thank you very much. Thank you.